Good morning, everybody. We are starting our second chapter, which is a great chapter. We're going to be graphing all 6 trig functions, and we're going to be modeling real-world behavior with sine and cosine. So graphing these functions, it's important to realize that they are functions. So they have a domain and they have a range, the domain and the range. And when we graph these on an xy plane, the domain is going to go on the x-axis and the range is going to be the y-axis. So you should, domain and range, those are mathematical words, they're important to know, but always realize that it represents input and output. So the domain is the input, the range is the output, and that's going to help us graph the sine function. So let's look at our unit circle. Here's our unit circle, and we're focusing on sine. And I want to develop several ordered pairs. Here's the domain, here's the range. Now, sine can only receive angles, so let's start with my second favorite number, 0. The sine of 0 radians is 0 because sine is y, and that right there, the y value is 0 on the unit circle. If I rotate up just a little bit to pi over 6, I'm just doing special angles, then the range value is a half because the sine of pi over 6 is a half. If I go over to the next special angle, which would be pi over 4, the range value is rad 2 over 2. So these are all ordered pairs that I'm going to graph. Let's skip ahead to this angle, pi over 2. That angle has a sine of 1. If I jump to, let's say, 2 pi over 3, that has a sine of rad 3 over 2. And again, there's no rhyme or reason to these. I'm just picking ordered pairs because I want to get a bunch of ordered pairs so I can graph the sine function. And 3 pi over 2 has a sine value of -1. But then when I get to a full circle, when I get to 2 pi, I'm essentially starting all over again. I'm right here all over again because the next one I would do would be that angle, and that's just 2 pi plus pi over 6, so that's 13 pi over 6, and that's the same thing as that one. It has the same sine value. It's not the same angle, but it's the same sine value. So I've got several ordered pairs. That's enough. That's got to be enough to get a good idea of what the sine graph looks like. That's the point, is to be able to construct a sine graph using the unit circle and for it to make sense. That is the point of today. First of all, sine has a maximum of 1. So let me just graph that right there. I know that when I graph sine, the biggest it's ever going to be is 1 because sine can only produce numbers up to 1. And the lowest it's ever going to be is -1. Okay, now let's graph. The first order pair I have is 0, 0. So that is right there. And then what's the next one? Well, hold on a second. All these domain values, they all have one thing in common. They're all in terms of pi. So I'm going to label my input axis, my domain axis, my x-axis. And I'm just going to label this right here as pi. I'll label this 2 pi. And that, of course, will be 3 pi. And if I go to the left, then make sure you're doing equal intervals. That's -pi, -2 pi, -3 pi. All right. The next one, pi over 6. Well, if you can imagine that distance is pi, can you imagine splitting that up into 6 equal parts? That 1/6 might be about right there. So a 1/6 of a pi will result in a half. So I will try to put an ordered pair. That ordered pair right there, that green dot, is pi over 6, comma, 1/2. That is an ordered pair that is in this function. And then skipping on ahead to pi over 2. So half of pi would be right in the middle there. Half of pi results in 1. Pi results in 0. 3 pi over 2, that's the same thing as 1.5 pi's. So here's 1 pi, here's 2 pi, 1.5 pi is right in the middle. So 1.5 pi's would result in -1. And then 2 pi results in 0. Well, if I were to fill in the rest of the ordered pairs and then many, many more, you would see that it forms this nice, very pretty curve. That is the sine curve, the sine wave. And it's periodic, which means a period means that something repeats. It's the smallest interval of time in which something repeats. And sine has a period of 2 pi. Every time you've traveled left or right a distance of 2 pi, things are going to start repeating. So when I continue my sine graph here, I can really think of it as being right here, because all those outputs are going to repeat. So I could just continue my curve right there to 3 pi, and then it curves backwards. What about to the left? What about negative angles? Well, the first quiz had a question like this. How are these two related? The sine of an angle and the sine of its opposite. Then these two functions are opposites, which means sine is odd, which means it's reflective over the origin. So if, like this ordered pair up here, this ordered pair is pi over 2, 1, that means that if I change the domain to its opposite, then the range will also change to its opposite. So negative pi over 2, -1. Here's another ordered pair. This is 1.5 pi's, comma, -1. So if I change the domain to its opposite, -3 pi over 2, then the range will change to its opposite, +1. So -3 pi over 2, +1. And the pattern continues. And that is sine. That is the sine wave. I would be very happy if you could, with a blank piece of paper, just use the unit circle to construct this sine wave. And here, neatness counts. Neatness counts. So make sure, I just, again, ask as usual that you participate and do the homework and graph these and try to make yours look like mine. So I'm labeling my x-axis, I labeled my y-axis, and try to be as neat as possible. And then cosine, very quickly. Cosine, lots of similar arguments. Cosine is still a function, and it has, but the cosine will produce the x value on the, oops, hold on. Cosine is going to produce the x values. So let's start again with my second favorite number, 0. The cosine of 0, well, cosine is x. So what is the x value right here? The x value is 1. So that's our first ordered pair, 0, 1. Let's jump ahead to some easier angles. Pi over 2. Pi over 2 has a cosine of 0. Pi has a cosine of -1. 3 pi over 2 has a cosine of 0. And then when you get to 2 pi, everything starts to repeat. 2 pi is the same, has the same cosine as 0. And then this one would be 2 pi plus pi over 2. So that's 5 pi over 2. And that has a cosine of 0. And then it just repeats. It repeats itself because cosine 2 is periodic. It repeats every 2 pi. 2 pi is the smallest interval for cosine to repeat. And also, like sine, excuse me, the largest cosine will ever produce is +1. The smallest it will ever produce is -1. So it's again oscillating between those two values. So let's graph and see. It's gonna look very similar to sine. Starting with this ordered pair. When the input is 0, the output is 1. So we start up there. Whereas sine started at the origin. Cosine starts up there, up on the y-axis, 1 unit up. Pi over 2. Okay, I gotta label my x-axis. I'm gonna choose this distance to be pi. So every time I do that distance again, that's another pi. So that would be 2 pi. And then 3 pi. Negative pi, negative 2 pi, etc. So pi over 2 would result in 0. Halfway between 0 and pi is pi over 2, and the result is 0. Pi results in negative 1. 1.5 pi's results in 0, and 2 pi, whoops, 2 pi is 1. Shame on me. Sorry about that. 2 pi results in 1. I had my sine in my brain. And this is one portion of the cosine graph. And then you can continue that pattern halfway between pi and the next pi. The cosine is going to be on what they call the midline, and it continues on. So, and also on the quiz, cosine and cosine of its opposite angle, these two were actually the same. They were identical, which makes cosine even. Now, since cosine is even, whatever the input is, if you change the input to its opposite, you're going to have the same range value. So like this example right here, this ordered pair is pi comma negative 1. Well, if I change pi to negative pi, the answer will still be negative 1. And then this ordered pair is 2 pi comma 1. If you change the domain 2 pi to negative 2 pi, the range will still be 1. So that's this ordered pair. That is a characteristic of an even function. And then you've got the cosine graph. It's worth mentioning, it's worth noticing that if you look at back to the sine wave, if you look at this portion of the sine wave, it is identical to this portion of the cosine wave. Because sine and cosine are very, very similar. They're complements of each other. That's what the co means. So you take the cosine wave and you shift it over 90 degrees, you're going to get the sine wave. And if you take the sine wave and you shift it over 90 degrees, you're going to get the cosine wave. And I'm sorry to use 90 degrees, I should say pi over 2. If you take the cosine or the sine and you shift them over pi over 2, it'll just overlap the other trig functions. So cosine and sine are very much related.